So good morning again. So quick question, how many people, it's their first Cisco Live? I love seeing the hands. That is just awesome. That is fabulous. I'm here to teach you troubleshooting multicast and to teach you multicast. Now the reason why I can be up here is because of the fact that in February of 2001, I learned multicast from Mr. Multicast himself, Bo Williamson, in a one-week class. So there's always that whole pass it on thing. I'm here because of him. And so I would very much like for us to all put our hands together for our guest speaker in the beginning for Mr. Multicast. Thank you.
So I've been around for a long time and started teaching multicast and put together the course that was a week long to teach people inside of Cisco. And then I started teaching it. I actually talked to one of the Cisco organizers and I said, hey, you know, you might want to have sessions on Saturday and Sunday before you start that are called power sessions. Now they're called tech sessions, and it's an all-day specialty. And I began to teach multicast in those as well. But the one-week class started at the very bottom, taught dense mode. You got to play with a lab in dense mode. And after that, you knew to run away from dense mode. And then we did sparse mode and did all of those exercises. It was a whole week long. Nowadays, if I think about doing a whole one-week class by myself like I did, I just go, oh. I've gotten a little older. One of the things I talked about was geek endorphins. That's why on some of my presentations there was a geekometer. Anybody ever see the geekometer in any of my presentations? Well, anyway, I used to tell people it measured geek endorphins, which is what your body releases as you play with technology, because I suspect everybody in here enjoys technology. But long-term exposure to geek endorphins is not good for you. And you can see I've been exposed to it for many years, but I'm only 28 years old. So you can see what it does to you. No, actually, what I'm doing is saying goodbye to everybody. This is my last Cisco Live. I've come here to hug my friends, see a lot of my old friends, Dino Farinacci, Greg Shepard, many, many more, and say goodbye because I'm really retiring. And in addition to that, it seems that I've contracted brain cancer. And so I'm now fighting a cancer called glioblastoma. And they were lucky enough to cut open my head and leave the multicast pieces in, but cut out the tumor completely. So that's a good sign, but this particular cancer is very aggressive. So I'm going to be doing chemotherapy for at least a year with the leading guy at Duke University, at Duke Medical Center in Raleigh. So I'll be going out there every 2 months and probably bothering her on the side when I go out there saying, are you doing everything right? Anyway, so this has been a ball. I've really enjoyed presenting. I think I did my first multicast presentation in about 96. And prior to joining Cisco in 94, I used to come to networkers. Anybody in here ever go to networkers? You know what I'm talking about? Yeah, that was the old days. So, yeah, that was great. So I've been doing it for a long time. And I thought, you know what? I'm paying my way here. I just got the Explorer Pass just to hang around the DevNet section and the world of solution. You know, that's part of the brain cancer problems. I get the wrong word. But anyway, I did want to come and say goodbye to everybody, and so that's what I'm here for. The introduction session was done by Tim. Everybody see him? Okay. So I was really worried. It's a new guy. It was his first presentation at Cisco Live, and I was a little worried because some first presenters, they know the subject, but they can't present. He got great scores, so congratulations, Tim. And here's the imaginary keys to Introduction to IP Multicast. You're in charge of it from now on. Work with fish. So any other questions or anything before I put the mic down, bug out, and say goodbye? A hug, of course, absolutely. I will admit that I had put some things out on Twitter when I found out I was not going to be able to do this. And I was at the bottom of my mental depression, suffering from some really serious chemotherapy and radiation. And then my cousin, who I was really fond of, also died. So I was at the bottom of my depression when I found out, oh, they gave it to Tim. So I said some bad things, and I'm sorry. And so that's why I needed to give her a hug and say, I'm sorry. So. Thank you. Anyway, thank you, everybody. And it's turned over to Tim and Denise, and have fun. There you go. And also buy my book. Thanks, everybody. Take it away.
Thank you, Bo. Thank you very much. Oh, it is off. Good. I didn't want you to sneeze and have like everybody. So good morning. Okay, troubleshooting multicast. My name is Denise Fishburne. You can call me Fish. And do I have the right one up here? Yeah, I do. Apparently, in another presentation, I accidentally, because it's 2019, I actually put 2019, and someone's like, I think you got your CCD number wrong. So I was like, oh. So I've been with Cisco for 22 years. And I did learn multicast from Bo back in February of 2001. And what happened was I bought his book and I did the class. So it was very similar style teaching. So it really, everything that I did got reinforced. And I fell in love with multicast. And I found it very easy. So I'm going to ask you a quick question. How many people find multicast easy? Yeah. I'm hopefully going to help you with that. So what I'm going to tell you is that 9 times out of 10, it is the same exact thing. And you're going to hear me say this, spoiler alert, you're going to hear me say this again and again. Who's the root? Where's the root? What is the PIM RPF neighbor for the root? Okay? And so 9 times out of 10, it is going to be that or one other thing. When you're doing anything having to do with ASM or SSM. I'm not going to ask you to raise your hands, but I do want to say that we're not covering dense mode. If you're doing dense mode, hopefully that was in the abstract clearly. If you're doing dense mode, I'm very sorry for you. But if you want to talk about dense mode afterwards, that's perfectly fine. But we're not actually covering that in this class. We're going to be covering ASM, which is any source multicast, and SSM, which is source-specific multicast. So who was at Tim's session the other day on Intro to Multicast that he totally oh, that was awesome. So for those of you who are at Intro to Multicast in Tim's session the other day, you're already one leg up. So just bear with me on the refresher stuff. So we're going to go through some refresher stuff. So what we're going to do is we're going to do a quick review of multicast because it's very common that a lot of you are not necessarily always thinking about what multicast is. So I'm going to say things like FHR, LHR. I may say IR, which is just a terminology that I tend to use, which is an intermediate router, which means it's not an FHR or an LR. It's just a multicast router. I seem to have caught that years ago and have not been able to let go of it. So I might say IR. So I'm going to say what some of the things mean. And then we're going to do troubleshooting multicast methodology. And then we're going to troubleshoot ASM. Who knows what ASM is? So basically what happened is when I learned multicast, it was dense mode or sparse mode. So people would say, well, what kind of multicast are you running? And you typically answered dense mode or sparse mode. And so what ended up happening was source-specific multicast came out. And then all of the documentation started changing, and all of a sudden this ASM thing popped up. I'm like, I thought I knew multicast. What's this ASM thing? Basically what happened was, because you couldn't now say, well, are you running, what kind of multicast are you running? And now you couldn't say sparse mode, right? Because sparse mode, you can sit here. I always need someone to kind of sort of, take some deep compression pressure from the people right here. What would basically happen is I would say, what are you running? And if you said PIM sparse mode, that's fine, but that doesn't tell me whether or not you're running normal PIM sparse mode or source specific. So then they came up to differentiate the two. Any source, meaning you need a rendezvous point. Source specific, meaning you don't need a rendezvous point. But both have PIM sparse mode on the interfaces. And then we're going to troubleshoot both. What you're going to notice is that when I go quickly through the slides for source-specific multicast, it's not because I don't love source-specific multicast. It's because a lot of the things that you're going to do to troubleshoot any source multicast are identical to when you're troubleshooting source-specific. So for the troubleshooting source-specific, we're just going to show the examples of what is the differences and the additional things that you'll troubleshoot in that environment. And then some final troubleshooting takeaways. Oh, right. I am honored to have Tim as our session moderator. I figure it's Thursday. By now, you've probably seen this slide a few times. We are in BRK IPM 2264, for those of you who think you're actually in a BGP class. And so Tim will be doing moderating for any additional questions that you have during the session. Oh, and it will be open for Tim and I to also answer questions too till the 19th. Cell phones. Turn them on. Turn the volume up. No, I'm kidding. I've never said that before, but it's like, cell phones, what are you supposed to do with them? Unless you want the person next to you to give you that look. It's all your big kids. Do whatever you want with your cell phones. This is just a reminder. This is an intermediate class, and so I'm going to assume some multicast operation. For those of you who are newer to multicast or you don't do it all the time, we are going to do a refresher in the beginning, which should set you up to be able to follow along for the whole rest of it. Questions, feel free to ask questions. I have been teaching troubleshooting multicast for a while. So everything that should be relatively intuitive, but you might get a text or sneeze or do something like that and miss something I just said. So please feel free to raise your hand with a question. If it's specific to your environment, please go afterwards, or if you're just dying to ask Tim. The only downside to that would be that then you might miss something as a setup for something else I'm going to teach you. Quick review, are we ready? Okay, we're going to do frequently used terms. We're going to talk about this is not exciting, but I'm supposed to put it up here. This is what we're about to do. We're going to talk about frequently used terms, and we're going to go ahead and talk about the tree growth, because you've heard people talk about it as a multicast distribution tree. Although I love Tim's analogy of the whole river and the water runs down. I love that. And then we're going to talk about sending a star, G join, registering a source, and designated routers. Frequently used terms, any source multicast. Any source multicast. So for those of you who are newer to multicast, I may call the RP, or the rendezvous point, the dating service. Okay? Somewhere on my blog or whatever, or it's out on packet pushers, there's an analogy of that. And so basically, any source multicast means that you said, I want to join this group, but I don't care who the source is. Any source. So ASM is any source multicast. It is what you probably view as just PIM sparse mode. Source-specific multicast, I kid, is you're married, you don't need the dating service anymore. Okay? So when you send the join, you specifically say, I want to join this group that is by this source. talk more into detail about that. Multicast distribution tree. Because this is not dense mode would assume that everybody wants to hear the multicast. So I, as the multicast source, send it. You as the first hop router, you just send it. It goes on and on and on and on until it gets to the absolute end where no one wants to hear it. And then there's a shut up, 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 shut up. And then 3 minutes later, it goes down again, okay? So that is the simplest view of the tree. In dense mode, it built from the root. In sparse mode, it actually is a pull, and that's one of the things you're going to have to look for. But we're going to get into more detail about that. And the rendezvous point. First hop router. It's the first router that sees the multicast. I know this one's tricky. Just try to work with it. So the first hop router is typically connected to the source of the multicast. It is the first router to see the multicast. Last hop router. It's connected to who? The receivers. So it is the last router to see the multicast. So it is connected to the receivers. There are certain things that a first hop router and a last hop router are supposed to do, which is why it's kind of important to remember those terms, because first hop routers are supposed to do certain things, last hop routers are supposed to do certain things. I may say IR as an intermediate router, I may not. DR is a designated router. We're going to get into more detail about that as well, but these are the terms that I may use going forward. So if you want to look it up or write it down or whatever, if you're very new to multicast. So DR, I'm probably going to use that term as well. DR, of course, would be if I am on a source, so Tim is the source, and Anas is another router, and both he and I are on the same subnet, and Tim is the source. Then one of us will be elected to do the first hop router responsibilities for that multicast source, as opposed to both of us doing it. IGMP. So if you ever hear people say it's an IGMP join and anyone shuts you down, and they're like, it's an IGMP membership report, dude. Tell them Fish said, yeah, I know that. Okay, but that's a lot of words. So Fish said I could just say IGMP join. Go deal with her. It's technically an IGMP membership report, but a lot of people do call it an IGMP join. PIM, Protocol Independent Multicast, that is the conversation that happens between the routers. PIM so multicast is high on the food chain. I also refer to BGP as high on the food chain, especially IBGP. So what happens with PIM is first you have your routing protocols. Let's assume they're dynamic and not static. Anyway, first you have your dynamic routing protocols, and then on top of that, you have your PIM neighbors, your protocol independent multicast neighbors. They're the ones that are going to start building the tree so that the multicast can get around. Trust me, this is not the first time you're going to hear this. What's supposed to happen is if it's a key takeaway, I'm supposed to repeat it a few times. We talked about this one, any source multicast, classic PIM. You need a rendezvous point. Source specific, you don't need a rendezvous point. So let's talk about the tree. I like visuals. So this is a frequently used term, so star comma G. So we always have the root of a tree, right? I said, who's the root? Where's the root? What's the PIM RPF neighbor for the root? So the root's pretty darn important. The root's really, really important in this tree. And we call them multi-disk, we call it that, but we also call it a multicast distribution tree. It's also referred to as an MDT. Basically, this is if you think of a tree and the nutrients that go out, that's basically what it is. You have your tree, and then the multicast goes out over it, out to the receivers, which are on the leaves. The biggest, weirdest thing about multicast is usually the nutrients go out this way and the root of the tree. But with us, the tree actually grows backwards, but we'll see that too. So for a star comma G, this is you said that you want to join group 239.1.1.1. Right? So the star means any. I don't care. I don't care, bring it. Well, if it's I don't care, bring it, then we need someone to hook us up. We need the rendezvous point. We need the dating service. Because a star comma G is just kind of sort of like, okay, I want to join this. Out of all of you out there, who's sending to 239.1.1.1? Yeah, that's not going to work. So what's going to happen is if you're sending to 239.1.1.1, you're going to go register at the dating service so that the rendezvous point where the sources and the receivers meet and live happily ever after, where the sources and receivers meet, that's where we're going to go ahead and meet up. So this is called the RP tree or the shared tree. I also, unfortunately, do tend to call it the star comma G tree. So I just tend to refer to it as the star comma G. But star comma G equals the rendezvous, the shared tree for everybody who wants to join 239.1.1.1. It's also called the RP tree in different terminologies so that when you read other stuff, you know, the terminologies make sense. I will call it the star comma G tree. The star comma G, if you think of it as the RP tree, the star comma G roots at the rendezvous point. Because if I want to join that 239.1.1.1, I, as the receiver, have to build a tree to get me to the rendezvous point so that then I can get everyone. And what if there's 3 different sources sending to that multicast group? Yeah. Well, you know, when you're dating, you might be dating more than one person. You know. So you're going to get all 3. Now, this may not be what you want because you might want to join the IPTV thing for your CEO who's talking, right? And again, that would be source-specific multicast. You know, first there was dense mode. They saw issues with that. You know, and then there was sparse mode. Then they renamed it to any source multicast because if I say I don't care who the source is, then those are the instructions for the multicast environment. I didn't care who the source is. Give me everything. So that's the star comma G tree. And the receivers are down here. So the last hop routers, now there's no source in here yet. Right, there's no source in here. This is what it would probably look like if a source hasn't come online yet. Everyone's just waiting. And they're all registered. Now, normally I'm a female, so I can get away with this. Men can't necessarily get away with this in intro to multicast sessions, which is a shame that we have different rules for men and women. But what we're going to do is we're going to say that the men are the sources and the women are the receivers. Okay? So in this situation, we have a whole bunch of women who have, as receivers, who have said, I would like somebody who likes to go bicycling. Or I would like 239.1.1.1. And that's all waiting there at the dating service. So we're waiting for someone who likes to go bicycling. So this is the shared tree. It's already built. Now we have the source tree. For the source tree, and this is specifically for the source tree, the first hop router is the, and that gets difficult. It's like, okay, is the source the root of the tree, or is the first hop router the root of the tree? Sometimes you might hear me say, and then the root is the source. You know, technically, of course, it's the first hop router, but I may interchange those two. To me, it's really kind of sort of one and the same. They're partners in sending this traffic. So the first hop router is the one that's connected to the source. I tend to refer to it as the S comma G tree. It will have S, will be the source IP address, 1.1.1.1, and then the group 239.1.1.1. Or it could be Bob, comma, bicycling. Right, for the other analogy, if that analogy works for you. So I'll tend to refer to it as the S, G tree. Some people refer to it as the shortest path tree. Some people just refer to it as the source tree. Remember, we're using frequently used terms and set up so that, because you're probably not doing multicast all the time in your environment, and then we're gonna get right into it. So here we go, we have the star, G is I say star, G, that's this. Means you're rooted where? So what is the root of the star, G? The rendezvous point. Everyone has had their caffeine. This is awesome. So what is the root of the S, G tree? Source. First hop router, source, whatever. Source. Okay. These are really hard terms too, kind of sort of similar to FHR and LHR. Okay. You have your incoming interface. Guess what happens? This is the traffic where the traffic is coming in. So your incoming interface, so when you're doing a show IP route or show MRIB on iOS XR, there's an incoming interface, and there's an outgoing interface list. I might sometimes refer to this one as the IIF because I've been doing multicast for so long, and some commands actually had this as IIF or IF. So this is the incoming interface, and I might refer to this one as the OIL, which is the outgoing interface list. Everyone who says that they want to, go bicycle riding with Bob. So the incoming interface is the interface that is towards the route because the traffic is going to come down from the route. Right? The nutrients come out of the route. So the outgoing interface list is interfaces that I have received a PIM join from, or an IGMP membership report. So, what does the IIF, or the incoming interface of the star, G, point towards? RP. So the incoming interface, right, I'm going to check, because I don't want to just take any multicast. So if something came in this way, but I'm expected it in this way, we're going to do an RPF check. That's why you see on the show IPM routes that there's an incoming interface. Because if that multicast came from somebody else, it's got to come from where I'm expecting it from. And I'm expecting it from the root of that tree. So for the star, G, I'm expecting it to come down the interface that is my connection towards the rendezvous point. So for the IIF, it's the rendezvous point. This is my way to get to the rendezvous point. So what does the IIF of the incoming interface of the S, G tree point towards? The source. Okay? A lot of people say that multicast works backwards, and I'm going to say that I don't agree with that. I think multicast is in many ways similar to unicast if you're not doing static routes. There is one thing that is very backwards, and that's the way the tree grows. So the way the tree grows is backwards to not unicast and stuff like that, but the way the tree grows is backwards to how we view trees are growing. Okay, so this is the thing I want you to let go of, because when I keep on saying tree, you're going to keep on having that frame of reference that works for you in your environment, which is reality with a real tree. I wasn't there when they called it a multicast distribution tree, okay? So in nature's environment, trees go up and out from the root. They go this way, okay? They start at the root and they grow out. With multicast, trees, we're not saying dense mode, okay? In sparse mode, it's a pull. It's a please send it to me. In dense mode, it was this way, but it was just like, and then shut up, shut up, shut up, shut up, shut up. In sparse mode, which is what I hope you're running in your environment, this is not the way they grow. They grow via a pull. They grow because someone cares. They grow because, as Tim said in his class, you turned to that radio station. You were like, I want to listen to this group. And you turned to that radio station. And because you turned to that radio station, we'll pretend that the radio station isn't already like in the air, okay? But you're pulling that into your speakers. Right? So you turn to that radio station, you're pulling it into your speakers. So that's what happens with multicast is you have to actually have the receivers at the ends that are connected to the last hop routers have to send that IGMP membership report or join, or you have to have a static IGMP. And that pull has to happen. And that's why I said that there's actually more than just who's the root, where's the root, what's the PIM RPF neighbor for the root. You also need that pull. Because ain't jack going to happen in sparse mode unless there's somebody who actually wants to receive the traffic. Okay? So what's going to happen is that because the receiver sent, so when you're troubleshooting, you have to know these things. So because the receiver sent the I want 239.1.1.1, then that will go back towards the rendezvous point to see if there's anyone sending to 239.1.1.1, because that's where the source of receivers rendezvous. So the knowledge of the root is critical. Who's the root? Where's the root? What's the PIM RPF neighbor for the root? Hopefully I'm not sending you all to any therapy next week. I keep on thinking, who's the root? Where's the root? What's the PIM RPF neighbor? But this is where, when I come into, I help people in multicast and CPOC all the time, and I teased this one guy, he was like a quad CCIE or a 5 CCIE. I'm like, no, seriously. Did you just want to see me? Because this is really, it's always the same stuff. But he'd always pull me in for multicast, and it would always be, who's the root, where's the root, what's the PIM RPF neighbor? Always, all the time. So what we're going to talk about is we have those three, who, where, what. And we also have that pull. So that pull, you're going to be troubleshooting. Did the pull happen? Because if the pull didn't happen, if no one said that they cared about 239.1.1.1, then you need to go back to the last hop router, and when people are like, I'm not receiving it. Well, did the last hop router, did the IGMP even get through? Okay, so you need to make sure that pull happened, because nothing else happens and the trees don't get built unless that pull happens. So here's another question. So the pull happens, so that receiver right there sent the pull, and we're going to assume that router A knows the rendezvous point as an IP address. We're going to assume it has the RP in its routing information base, and we're going to assume that we have a PIM neighbor. So we're going to assume we know who the rendezvous point is. We're going to assume we know where the rendezvous point is, and we're going to assume we know what the PIM RPF is for our neighbor. So assuming that, I have a question for you, and it's okay. Regardless of how you answer this, you can raise your hand, because regardless of how you answer this, it's just confusion. All answers are somewhat right, okay? I mean, there is one right one, but there's reasons why you think it's other things. So when router A sends a PIM star comma G join out, what will be the destination IP address? So I got the receive, I got the pull, you want 239.1.1.1, okay? And so I go ahead and as the last hop router, that's one of the reasons for the IGMP, that's one of my roles, is to take the IGMP join membership report and then start to pull down. So I make a PIM join out of it, and I go to you and I say, I send a PIM join to you, and I want to join 239.1.1.1. Now, once you get it, in theory, you're going to then go ahead, branch by branch, hop by hop, because you have a leaf, and that goes to one branch, and then that goes to another branch, same thing. So you're going to send a PIM join, PIM join, PIM join, PIM join, and then we're going to, pull it down. But here's the question. So when I send that PIM join to him, what is the destination IP address in that packet, right? I have to make the destination IP. I have to put something in there. So is it the IP address? I'll give you all three answers first. Is it the IP address of the rendezvous point? Is it 224.0.0.13? Or is it the IP of router B? So is it the rendezvous point? Is it 224.0.0.13? Is the destination IP his IP address? Yeah, you know, I can do math. There's a lot of you who didn't raise your hand. Okay, so I'm actually going to tell you that if you go to the RFC, which is RFC 4601, what you'll find is that when I send a PIM join, it's actually to all PIM routers. Okay? Now the other ones, and that does get confusing, right? Because if I send it to the rendezvous point, destination IP address rendezvous point, you're going to ignore it because you're not that. Okay? So if I send it just to you, then we have another problem. And we'll talk about that other problem. Okay? So we have another problem. And so I want to send it, and so this is why we must have PIM neighbors. As Tim taught in his class, any place that you want the multicast to run over, you have to have a PIM neighbor for it. Trust me, by the end of this class, you're going to lag. You're going to know everything. Go ahead, like take the PDF, teach the slides. Okay, so that's what's going to happen. So let me tell you, so it's going to be all 224. So it's going to be this one right here, 224.0.0.13. So the dip, I'm sorry, I call it sip and dip. I have for years. I'm just a lab rat, so I kind of sort of make up my own terms sometimes. So SIP is source IP, DIP is destination IP. So the destination IP, so when I send that PIM join out, when I send the PIM join out to you, I crafted the PIM join saying that he wants to join, that I want to join, 239.1.1.1, and then I tack onto it to get your attention, the destination IP of all PIM of 224.0.0.13, all PIM routers. Okay, so then the question becomes, if that's the case, so if the destination IP address of the join is 224.0.0.13, all PIM routers, then how do I keep him? How do I keep George from not also acting on it? Right? So I'm PIM neighbored with both of them. So what do? Do both of them pick it up and then I get twice as much traffic? Actually, no. I'm so sorry, but you have a hat. So here, I'll give you a hug. And actually, I'm going to say thank you, and please feel free. I really want you engaged here. We do hesitate because we have fear and pride. Okay, so please feel free to engage, because the more you engage, I think honestly, the more you'll learn. So what's going to happen is, and these are the basic concepts that do get confusing. There is actually an advanced command. We'll probably charge you extra money for it. No, I'm kidding. There is multicast fast reroute. That is where you actually will pull down more, because people did want that. And so, but they didn't think about that when this first came out, because back then, CPU and bandwidth and things like that were so critical. Now we don't even think about that. Now, if they were to create it now, they would probably do both. Right? But back in the day, I don't want it from him and him. So how do I decide? I mean, he gets it, 224.0.0.13, right? So what do I do then? So if the destination IP address of the join is 224.0.0.13, how do I keep Cody and George from both acting on it for me? So again, going back to the RFC, there's an upstream neighbor. Now, someone said, okay, so that's like your OSPF upstream neighbor. Well, I'll be honest, it's in a PIM RFC, so it's probably your PIM upstream neighbor, which it is, okay? So it's your PIM upstream neighbor. So what's gonna happen is you're going to go ahead and in the PIM message, you're going to put inside of there, and I'm visual, so you'll see this in a sniffer capture. So I'm going to put the upstream neighbor of him. So the DIP, the destination IP, will be 224.0.0.13. You'll both pick it up. And then you'll see, I'm not talking to you, but you can just go back to playing golf or whatever you were doing. Yeah. And so I will get your attention because since I did 2240013, and some people have said, well, why didn't you then just use your MAC address? So 2240013, but your MAC address is the destination. Well, that would be violation, right? Because if it's 2240013, I have to have the destination MAC address that matches to that. So here we go. And this is kind of sort of how all answers are right. I love sniffer traces. And so the destination IP address is 2240013. So that's the destination IP address. But down here in the PIM parameters, I have your IP address so that George will go ahead and ignore it. But this time because I told him to. Yes, sir?
How do I know that he was the one that I wanted to send it to?
We'll get there. The question was, how do I know he is the one I wanted to send it to? That's coming right up. Thank you very much. I appreciate that. Keep them coming. So this is the IP address of Cody. And then I do actually put in here the rendezvous point. So that's why I think there's some confusion, because if you ever look at a sniffer trace, all three are there, right? All three that you raised your hand for or you didn't raise your hand for. So then the question becomes, I guess I have it later on. So to answer your question, so how do I know that it's Cody that I want to send it to? Well, it's because of the fact that I heard George is really lazy and Cody's more responsible. No, I'm kidding. We are actually recording. I just know to let you know, actually this will go out on Cisco Live for anyone in the entire world to watch around the entire world, yeah. For free. You don't even have to have gone to Cisco Live.
Can you use my last name and his last name?
I don't think I can do that part. I'm stupid, but not that stupid. So how do I pick Cody over George? And the concept actually is that I will, by default, if I have both in my routing information base, okay, I will, by default, pick the one with the highest IP address. Okay? Okay, so this is going to hurt your brain. That's okay. You're barely going to troubleshoot here, and you're going to see this another time. So pay attention, but if you're a little bit lost, that's fine. This one gets hard. That's why I got the little guy up there. So what's going to happen for the first hop router, so when we're registering a source. So now John comes online, and he is a source, and I'm the first hop router. So he just starts sending. So what's going to happen is, and this is back with the RFC as well, and so I will say that, again, this part's confusing, but there are certain time frames where you'll be troubleshooting here. So remember that there's something kind of sort of strange. So if the symptom is that the traffic is making it to the first hop router, but it's not making it to the rendezvous point, then go pull this slide up. But that's the symptom. It's making it to the first hop router, but it's not making it to the rendezvous point. So here's what happens. According to the RFC, again, 4601, we're going back in time, right? So with 4601, what it was the multicast comes online, and then I, as the first hop router, am supposed to, there is no dense mode. So there is no multicast tree that I can put it over. And all trees are supposed to be built backwards. That's something that you have to remember. Now, you saw that with the receiver. But it's strange to think about the source tree being built backwards. So this is what happens. So I get the traffic, and then I go ahead and I look and I figure out who's my route that I'm going to try to build this tree for. It's the rendezvous point. So who is my rendezvous point for, I might have multiple dating services, right? I might have dating services for sports people. I might have another dating service for people who are in other countries. So I'm going to look at your group, and I'm going to see which rendezvous point, which dating service I'm supposed to connect you up with. And then I, as the first hop router, have instructions of what I do is I take each packet that you sent me, and I send a PIM register join on, and the destination IP is the rendezvous point. It is unicast. Now, if that's confusing, just remind yourself that all multicast distribution trees are supposed to be built backwards towards the source. Okay, and we're not doing dense mode. So what's going to happen is that I'm going to get the multicast data, and I, as the first hop router, I'm going to take each multicast data that he sends me, and I'm going to slap a PIM header on it, and then I'm going to slap a destination IP on it of the rendezvous point. And then I'm going to send it unicast. Unicast is, by the way, to let you know, that's my arrow that goes that way. So if the arrow goes this way, it's kind of sort of, I'm going around everything. Okay, so I'm sending it unicast. Now, what does that mean? That means that any filters that are blocking certain multicast addresses on the way to the rendezvous point, I'm going to bypass. It also means that I better be able to get to the destination IP of the rendezvous point all the way through, because I'm going unicast all the way through to the rendezvous point. So I need to know how to get to the rendezvous point on the way there. And if you have multicast filters, I'm not going to hit them until the way back. So the rendezvous point sends a PIM star comma G join back towards the source. So the rendezvous point is like, okay, Bob, bicycling. And then so it sends a PIM S comma G join, and it says, where is the source? Where is 10.1.1.1? Where is he? And then from over there, it goes backwards, hop by hop by hop. Now, why that's important is because of the fact that if anyone on the way back doesn't know how to get to 10.1.1.1, it's broken. Who's the root? Where's the root? A lot of times, people don't think that they have to advertise the multicast source subnet because the traffic is going that way. Okay? But the tree gets built backwards. So if anyone on the way backwards doesn't know how to get to 10.1.1.1, they won't know where. They'll know who the root is because they got the PIM S comma G join, but they won't know where the root is. And the root is, again, back where the source is. And if there's no multicast neighbors, see, because if there's no multicast neighbors, all I do is check, before I send that unicast, I just check that I have a neighbor. Now, if I don't have a neighbor, I'm not that stupid. Okay, so I won't send the unicast. If I only have PIM here, the source, I won't be that stupid. But as long as I have one, hope springs eternal. I send it to the rendezvous point, and as soon as the rendezvous point notices it has one, then it'll send the PIM S comma G join. But if that's as far as we go and there's a big black hole in between and people forgot to put PIM multicast on there, yeah, not so much. So the RP sends the S comma G join backwards, hop by hop by hop, and then hopefully it makes it to me. And then I put an outgoing interface list on where I got that. Now, meanwhile, we're going to actually, so the next packet, so I get the oil, the next packet comes, and I still send it unicast. Okay? I still send it unicast. Now, I saw that I added to the oil. So the traffic came down. I got the PIM down. So the PIM join came down, but I don't know that the traffic will actually make it over that native multicast distribution tree. So we're going to get duplication. This is normal in multicast. Your multicast applications need to be able to handle this. So we're going to send it unicast still, and we're also going to send it out the native S comma G tree. Once the rendezvous point actually gets it via the S comma G tree, it will send a register stop. And then we move just 2 packets now over the S comma G tree. DRs. So what happens here, this is also actually, so what happens here is we have Cody and George again. And so we have a source. So I'm the source, and I'm just sending traffic. And again, you know, George is lazy, but I, as the source, can't, you know, I don't say who I want to send it to. I just start sending to 239.1.1.1. And so from that perspective, what happens is both of them are listening. Now, how many financials do we have in here? So with financials, you all use an A feed and B feed. So what you do, which Cody might actually want sometimes, is not to neighbor with George, okay? So what happens in financials is they actually don't, they block themselves from seeing each other as neighbors. So that when I as the source send, they both will pick it up and send it down. That's called A feed, B feed. That's a high availability of the multicast streams because it's your stock trades. And, but usually what you'll do is one of them will go ahead and become the DR. The default priority, which I thought originally was very stupid before I wrote this class, is that Cisco picked was a DR priority of 1, which I thought was like the dumbest thing. And then I actually read in the RFC that they actually tell you that the default priority should be 1. I was like, oh, okay. So the default priority of all your interfaces are 1 because that's what the RFC says. So if you don't change the default interface, then the one with the highest IP address becomes your DR. So which router should register the source with the rendezvous point? So the FHR, that's the DR, which is router A. So now we have a receiver, same exact thing. So which router should send the PIM star comma G join? I'm sorry? Route .3. Yep. Okay, so here we go. So I don't like, I really don't, I mean, I get what people say about it being backwards. The distribution, the creation of the tree is backwards. But I'm going to argue that it's not, it's backwards from the way trees are built. But I'm going to argue that multicast isn't that much different than unicast. You ready? So point A wants to talk to point B. So we want to ping. So point A wants to ping point B. Right? So what do? Well, if we're running a dynamic routing protocol, like EIGRP, so no statics here, dynamic, because that's what PIM is. PIM neighbor is a dynamic thing. Then what's going to happen is first you're going to have a routing protocol. For multicast, it's going to be PIM, which is going to be higher on the food chain above the EIGRP. But here it's unicast, so it's EIGRP. Oops, it's not there yet, sorry. And so that's EIGRP between them. Now what's going to happen is we're going to go ahead and this router way over here is going to advertise that subnet. Right? Because unless you're doing, I mean, you have to build the plumbing back also. We just don't necessarily think about that. Right? So before A can get to B, the plumbing has to be built. The unicast tree, the rib, has to be built. So this guy at the end advertises 10.1.1.0, and then the next one advertises it, and we're building the pipe. Next one advertises it, we're building the pipe. And then the ping goes through the pipe. So let's look at it from a multicast perspective. Now, in this example, we're going to assume that we're not going to cut over to the S comma G tree. I haven't explained that yet, but in case you go back to the slides later on, I'll have like a little note. So instead of EIGRP, we're going to have PIM. We're going to have protocol independent multicast. And so this last top router has sent the pull. So this is the IGMP membership report. Very big because nothing happens in sparse mode without that pull. So we're going to go ahead and that guy is going to say, okay, PIM star comma G. I don't care who the source is, but we need 239.1.1.1. And just like with EIGRP, that prefix was advertised over the EIGRP neighbor. This desire for 239.1.1.1 or somebody who bicycles gets passed on. And then the plumbing gets built. Now, at this point in time, we've made it to the rendezvous point. That's as far as we can go with the star comma G, as far as we can go, because we're not dense mode. So meanwhile, the source starts up for 239.1.1.1. And as you know, we do the unicast for the rendezvous point. And then we go ahead and we do a PIM's S comma G join on the way back. Voila, we have our plumbing. So I hear when people say that multicast is backwards. Again, I do agree that it's backwards from the perspective in our minds of how trees work. But we can see from a unicast perspective, we build the plumbing. I do troubleshoot backwards. Yes, sir.
So on the previous one, so at any time when the stream is active, is there a unicast stream going to the RP and the multicast stream?
So the question is at any point in time, is the unicast stream also going with the multicast stream? So what will actually happen is, come on, you can do it. Wow, I didn't realize it was that far back. So what happens is once the first multicast packet gets to the rendezvous point, we are now good, and the purpose of sending that S, G backwards has been done. The plumbing is there because we got it. And then we send a register stop to the unicast. Going to apologize. Everyone else can close their eyes, and for those on video, I didn't realize it was that far, quite that far back, sorry. Does that make sense? Perfect. So in solving a problem, so I do troubleshoot backwards. But is that really that uncommon? Right? If you were going to ping from me to someplace else, the first thing that you would probably do is go to my router right here, and you would make sure that you knew the destination IP address that I was trying to get to. But it's over there. But you're troubleshooting backwards. Do I know? I don't know. Where do you go next? I don't know about you, but I tend to go way over there on the other side to figure out why that subnet didn't make it over here. I don't go to the next router. Oh, well, okay, I don't know. Well, do you know? No, do you know? You know, I go all the way back over. So if I don't see it, then I go all the way back over. Similar to how I troubleshoot with multicast. In solving a problem of this sort, the thing is to be able to reason backwards. And so this is a very useful thing, but not a lot of people practice it. But this is what you're going to do for multicast. So if the multicast distribution tree is built backwards towards the root, and the traffic goes this way, I'm going to follow how the plumbing got set up. That's for SSM. For ASM, this is for SSM. This goes all the way back. The traffic goes this way. I'm going to troubleshoot this way. Right? If I can't ping in this direction, then yeah, I'll check right here. But then I'll probably go way over there and see if the network statement's in there. And then is there an access list on the way back? Not uncommon for how I troubleshoot. Troubleshooting facts to remember. Multicast routing must be enabled globally. So you have to say, by default, IPv4 unicast is on. If anyone does IPv6, you'll notice that you have to say globally IPv6 unicast routing. Same thing with multicast. IPv4 multicast routing. So you have to enable it globally. You have to have PIM on all of the interfaces. Multicast trees get built backwards towards the root, and the multicast traffic in the ASM and SSM are triggered via a pull. Boom. We ready? Are we solid? This is getting you solid. Okay, good. Let's go. It's high in the food chain. So if you're underlying routing, like you didn't advertise the source of the multicast, of the multicast source, you know, it's high on the food chain. Who's the root? Where's the root? What's the PIM RPF neighbor for the root? Now we're going to start troubleshooting. IGMP membership report needs to be received by, so we have who's the root, where's the root, what's the PIM RPF neighbor for the root? And then you also need to check that the pull was there. With IPv4, you need to know that the last hop router actually received that IGMP membership report for that group. No firewalls, no access lists, no issues. For IPv6, it's an MLD pull. Same concept. You need that pull. Who's the root? Where's the root? What's the PIM RPF neighbor for the root? Go ahead and take this, put it up as a piece of paper, right? And this is it right there, okay? knowledge of the root, and do you have a PIM neighbor? A lot of people think that they don't need a PIM neighbor, but you need a PIM neighbor. These are my go-to commands for iOS and for normal routing. If you're in XR, it's going to be different, but it's basically show me the multicast routing table, show me the multicast routing table count, like tell me what's going on. Show IP PIM neighbors, show IP PIM interfaces, show IP IGMP group, that's at the LHR, show IP PIM RP. This will tell me, like if I put 239.1.1.1 in there, it'll tell me who the RP is for that group, or who I am configured to believe the RP is for that group. Could be messed up. So you could do a mapping and also show IP RPF. Now I will say that I have a pet peeve. I have a pet peeve, Cisco. I have a pet peeve that it's show IP RPF. In a Nexus environment, it's show IP PIM RPF. So that does annoy me because it's not, this command is not related to normal unicast. This command is related to PIM. So show IP RPF is going to give you what the reverse path forwarding tree is for that. This is our environment. We're going to troubleshoot. So basically a lot of slides are going to be us troubleshooting hop by hop. This is our environment. So we're going to do ASM troubleshooting first. So in our ASM troubleshooting, what I have is I have R1, it's a CAT 9300. The rendezvous point is iOS XR. Then Nexus, CAT 9300. Just to kind of sort of mix it up and do some flavors. So ASM troubleshooting. We're going to break it down into multiple sections. Now, what you're going to hear me say is that I tend to troubleshoot, so a lot of the stuff that we're doing is going to be troubleshooting and starting with the receiver. Why? Because I rarely get called in if there's no receivers. The multicast is broken. Who's not getting it? Well, we don't have any receivers yet, but it's broken. So I usually get called in, so I usually troubleshoot from the perspective of I have a receiver not getting traffic or the traffic is flaky. So that's the way that I tend to troubleshoot. So what we're going to do here is we're going to break this into a couple different steps. Number one, the first thing that has to happen is I have to get these, so from the pull, the next thing that has to happen is I have to hook up the receiver and I have to get that I want 239.1.1.1 to the rendezvous point. That's step one. Step two, the source comes online, and again, the source could have come online before, but again, since I troubleshoot typically from the receiver's perspective, I usually check that one first. So the source comes online, sends the unicast, and then we cut over and we join that. So that's the next section. So there's between the rendezvous point and the receiver, between the rendezvous point and the source. Now what's going to happen is if you have a man and a woman, or you have a boy and a girl, and they both live in New Jersey, 2 blocks away from each other, but the rendezvous service, the dating service, is in New York. It's a little illogical for them to always have to go to New York to meet up. Okay? This is the same thing for us. Your rendezvous point could be up in your head end, and you could have multicast at your branch between like a bunch of routers down there. So once you've met each other, you can cut over to the shortest path tree. You don't need the rendezvous point anymore. You can just go bicycling together to your heart's content. Okay? So the last thing, and this is a frequently forgotten fact, the last thing is we're going to cut over to the S, G tree after we get the traffic down. First, we're going to focus on this one. So this is the building the pipe in this direction. It's going to have a couple different scenarios. One scenario is going to be that we need the pull. So we need the pull. So once the pull happens, then R5 will send a PIM star comma G to R4. We'll talk about why we picked Cody over George. So we're going to send that PIM star comma G to R4, and then R4 is going to send a PIM star comma G to the rendezvous point. And then we're done with this one, but we're going to go ahead and break it on the way. So 1A, this is going to be 1A, 1B, 1C. We're going to go to 1A first. So this is your troubleshooting tips. Remember IGMP membership report because we're doing IPv4. And all of these work. It's just you have to change the first one to MLD. But if you're doing IPv6, all of these work. So R5 needs to know who the rendezvous point is for this group, for 239.1.1.1. R5 needs to know where the loopback is, and R5 needs to have a PIM neighbor to send the star comma G join to. So here we go. Show IPM route. I am in R5, and I do a show IPM route, and I have absolutely nothing. This is actually a clue. So for those of you who know multicast, and I'm in a generic router, not iOS XR, and you have PIM enabled on any interface whatsoever, if I do show IPM route, will I get absolutely nothing? No, I'll get the auto RP stuff, right? Okay? So the fact that I do a show IPM route and I see absolutely nothing, that's a clue. So for those of you who have knowledge that that's not normal, what does that mean? Something's basically broke. Okay? Something more basic than I don't have a PIM neighbor. May I put this here? Thank you so much. So basically what's going to happen, it's completely empty. So for those of you, I do a lot of teaching of network detective, so you have knowledge that that's not normal. So I'm going to do a show IP IGMP group, and that's completely empty. Show IP IGMP interface, and that's completely empty. So basically what we're going to do is we're going to do a show run on the interface, gigabit 105, which is my interface towards the receiver. And what we're going to see is I have no PIM on there. Okay? When I said we need PIM on all interfaces, I also mean that we need PIM on the receiver end. We also need PIM on the multicast end. So you can send your IGMP memberships report all you want, but I'm not listening for that. Now, 224005 is what? OSPF. Okay? So if I don't configure, when you actually put OSPF on an interface, you're doing two things. Well, you're doing multiple things. One, you're going to start listening for 224005 and 224006. You weren't before. Two, you're going to go ahead and possibly neighbor up unless you're passive. And then you're going to start advertising stuff. So when you put PIM on, we're actually going to be starting to listen then to the multicast address that the IGMP membership report is sending. Otherwise, we're ignoring it because you have not instructed us to do so. So PIM's not enabled. So we need to put PIM, we're going to put IP PIM sparse mode on, and then we're going to run that command again. So we do show IP mroute, and this time we get a star comma G. This is what we expected before, kind of, sort of. This is the auto RP group. So when you do show IP mroute and you see 2240.140, this is the auto RP group. This does not mean that your multicast is working. That is not 239.1.1.1. Okay, so we're still broken. But at least we're one step further. So we have 2240.140, which means, okay, at least, look, we can at least see that PEM is enabled on gigabit 105. But we've gotten a little bit further, but we're not there yet. We do a show IP IGMP group, and we don't see 239.1.1.1. So what we're going to do here is we're going to go ahead and say that this is basic, so the IGMP membership is not being received. So the IGMP membership is not being received. So this could be that PIM is not enabled. We took care of that one. This could be that there's a layer 1 issue between us or a layer 2 issue between us and the receiver. Could be an access list that you have on the physical interface. Could be we're connected to a switch, it's not sending it on. Or IGMP membership reports not being sent. Okay? From our perspective, it was that I wasn't sending it yet. Okay, but these are the basic troubleshooting that you're going to do. So now we're going to go ahead and we're going to send the IGMP membership report and say, hey, send me 239.1.1.1. So we do a show IP IGMP groups, and we see 239.1.1.1 interface gigabit 105. Now the last reporter is 100.1.100. Don't get too tied up with that. So if you have somebody else who's not receiving traffic and they're at 4th octet 101 and you don't see them here, the last reporter, multicast actually had like suppression, so it's not this command that you'd be using to see what groups. You're going to want to be looking into like snooping and some other commands. This is just overall what groups. And what happens is with IGMP version 2, whoever was the first one, there's some suppression that happens, and whoever was the first one who said, yeah, that's me, they're the ones that if they leave the group, they're supposed to leave. But that's just like too much work, so now everyone just leaves. It's just too much work because there wasn't anything in the specs that said that you couldn't leave, but if you're the last reporter, you must leave. But all implementations pretty much just said to leave. But it's there, so this is good. So now I do a show IPM route, and I have a star. I don't care who the source is. I want traffic that's being sent to 239.1.1.1. So here's my star, comma G, 239.1.1.1. Now, my rendezvous points, there's a little problem, but you know, it's not quite there. But at least 1A is done. 1A was supposed to be the pull. I see the pull. So from this perspective, you can see that I see the pull. Now, there's other problems, but the pull's taken care of. So this part here is taken care of. And now we're going to switch to the next part, which is now that I have the IGMP in the pull, I now have to send a PIM join. So now we have to go to R5 and say, who's the RP, where's the RP, and do we have a neighbor? So let's go ahead and go there. We do a show IP mroute 239.1.1.1. And we notice that I have RP 0000. Now, this part gets a little bit confusing for those of you who know multicast already. In some implementations, like on iOS, this could actually mean that you're the rendezvous point. I'm not a big fan of that. Not a big fan of that, Cisco. Not a big fan of that. With XR, it'll actually put up here that its own IP address, and then it'll be like incoming interface, decapsule, tunnel, 0, whatever. But in a lot of iOS implementations, it'll just have 000, which is supposed to mean you're the rendezvous point. I'd really love our IP address to be put in there. Okay? So anyway, but from that perspective, this is still kind of strange, and I have no incoming interface. If I do a show IP PIM 239.1.1.1, though, it gets a little bit more detailed. If I was the rendezvous point, my IP address would show up there. So I don't know who the root is for the star, comma G. Who's the root? Where's the root? What's the PIM RPF neighbor for the root? So I don't know who the root is for the star, comma G, and that's what I'm trying to work on right now is the star, comma G. So that's strange. So from our perspective, I don't know who the rendezvous point is. You can have the rendezvous point via 3 different ways. You can do it statically, you can do it via AutoRP, or you can do it via BSR, which is the Bootstrap Routing Protocol. Years ago, AutoRP and BSR were the preferred. I prefer static because I prefer static using some type of Anycast RP methodology of either MSDP or RFC 4610, which is PIM-free. So I prefer so that if you're pretending to be 10.1.1.1 and you're pretending to be 10.1.1, I will kid that all virtualization is just a lie, so they need to make sure that their stories are straight. That's MSDP, right? So I go ahead and I just, in everybody, I put IP RP 10.1.1.1. Now, if you went to Tim's class, you'll know that the statics are actually overridden by dynamic, so AutoRP will override it, but at the end, you could just say override. It's like, my RP address will be 10.1.1.1. Override, that means I mean it, okay? And so then you can have that. So I prefer statics, but I'm a bit of a control freak. So I'm going to go ahead and put in here IP PIM RP address 2.2.2.2, which is R2, which is my rendezvous point, and I'm going to toss override on there. Now, no one today is doing auto RP, but I want to build today with tomorrow in mind, so I'm going to go ahead and put override on there, or maybe someone accidentally tosses it on. It's like, no, this is what I want. Configure with intent. So I put that in there, and now we go and we do IP PIM RP address 2.2.2.2. Now, what I could do is I could have done, even though I did this, so as you see, override dynamically learns over the auto RP. So while I did this, I could have also made access lists. So if I had a dating service for, sports enthusiasts, and I had a different dating service for a different type of group, and I wanted them to have 2 different RPs, multiple dating services, okay? So then you could use the access lists. So I put the PIM neighbor in, I did override, and we do show IP PIM RP is 239.1.1.1. So we now know who the rendezvous point is. So my little green light checks there, we know who the rendezvous point is. So now we need to know where the rendezvous point is. So show IP PIM, that's good, all of that's good. Whoops, that wasn't supposed to happen. So I do a show IP mroute 239.1.1.1. I know who the rendezvous point is, awesome. Do I know where the rendezvous point is? No, I don't. My incoming interface that's supposed to point to the root of the thing, I don't know. Okay, so I have no, so this is not good. That part's not good. So if I do a show IP RPF 22222, it fails because no route exists. Now, then I go ahead and I do a show IP route 22222. So not only do I not know the RPF neighbor, but I don't know where. And that's because, yes, sir?
So do you have to define, if you're doing static, do you have to define the RP on all of the downstream routers?
So the question is, if you're doing static, do you have to define the RP in all the downstream routers? Yes, everyone has to agree who the static is. You can let it be auto RP. If you let it be auto RP, that's fine. Just still use the IP address of this. So if you want to do auto RP, that's fine. I'm a bit of a control freak. Auto RP can have a scope mechanism as to how far it gets out. Then you add a router and it didn't get to the next guy. So I would prefer to go ahead and do static everywhere than to have to troubleshoot something because I didn't. So show IP route. So basically what was happening was R3 and R4 are not OSPF peered at all to R5. How exciting. So now we're going to go ahead and we're going to peer to, we're going to have R3 and R4 peer to R5. And now that they peer to R5, what you'll see is I have two ways to get there. Okay, so now at least I know where it is, though. So I've solved where, right? So now I know where it is. So second check mark. Now, what is the PIM RPF? What is my reverse path PIM neighbor that I'm supposed to port to? We're going to get to that one now. So now, we have our incoming interface. It's still null. So we know where it is, but that's not going to show up here because this is a PIM. This is a multicast routing command. So I don't know which is my RPF neighbor. Well, but I said that the one with the highest IP address would be the one I pick. If what? If I have PIM neighbors. Okay, so show IP RPF 2.2.2.2, still not there. No joy. Show IP PIM neighbor. I'm not neighbored with them. Remember, all interfaces have to have multicast over it. And when I do the PIM join, the destination IP is going to be 224.0.0.13. I'm not that stupid. I have no neighbors. I don't think anyone's listening. So I need to fix that. So now we go ahead and we put IP PIM sparse mode on both interfaces to R3 and R4, and the PIM neighbor comes up. So now we get back to I have two choices, and I picked R4. And the reason why I picked R4 is because 10.4 is higher than 10.3. So if we do a show IP RPF neighbor, it'll tell you this is my reverse path forwarding information from a PIM perspective. And so I picked R4. So now, why was 10.4.5.4? If ECMP is available, the RPF for the multicast traffic will be based on the highest IP address of the RPF neighbor. So now we do a show IP mroute. And we know who the rendezvous point is. We know where the rendezvous point is. And we know what the PIM RPF neighbor is. And so from that perspective, we have gotten to R4. Now we're going to go ahead and jump over into R4. Oh, this is the whole thing, by the way. That was the star comma G, the RP, the flags, a big S. The flags are different on different operating systems. The big S means any source multicast. Small s means source-specific multicast. Incoming interface, RPF neighbor, and outgoing interface. So now R4 has it. So we're going to go ahead and go to R4. And so here's something interesting that drives people crazy in CPOC. So basically, if I'm troubleshooting multicast, what will happen is I'll start in one router and I'll telnet backwards. Now, I'll go into somebody else's environment, and they're like, oh, well, R4 is this IP address here. Well, I'm troubleshooting. So if I'm troubleshooting, what I'm going to do is I'm going to go ahead and I'm going to telnet to who I just sent that PIM join to. I'll trust you all you want, but I'm going to go ahead and verify, okay? And it's been this sometimes. So I'm not going to assume you could have duplicate IP addresses, something else could be happening. So I'm going to telnet backwards. So I'll actually telnet backwards as I troubleshoot. And I'll do that in unicast routing as well too. Because this is who my router, so I'm going to go from my router's perspective, and I'm going to telnet, and it's going to bring me to R4. And in R4, I'm going to do a show IP mroute, and in R4, I already knew who it was, where it was, and what it was. Because I'm not going to be mean to you and put like no PIM neighbors and no OSPF neighbors, and I didn't know who the RP was and all that kind of stuff. So then once I've sent it over, so now I've sent the star comma G join to the rendezvous point, I'm going to go from R4 and I'm going to telnet to who I just sent the PIM star comma G join to, which is 10.2.4.2. Now this looks scary, show mrib route, and it's like, okay, well this is me, but this is iOS XR. But it's the same thing. They just call it the multicast routing information base. But I have the OIL, which means that I received it. So we're good. So from this perspective, we've got the pull, we sent the PIM, and now we're set and ready. So the receiver is waiting for Bob, who's bicycling, or for our source to send to 239.1.1.1. And now we're going to go ahead and we're going to shift focus, and we're going to go over to here to the first hop router registers the source. So we talked about this a little bit. What's going to happen is first the traffic is going to send. Then the unicast is going to register with the rendezvous point, and then the source is going to get built backwards. So let's go ahead and do it. Show IP mroute. Nothing. This is just to reinforce to you that, again, we have no PIM neighbors. We're going to completely and totally ignore 239.1.1.1 because it's multicast. You didn't have PIM on the interface, so we're ignoring it. So we see auto RP, but we don't see 239.1.1.1. So we put PIM on, and we do a show interface counters. And we're getting a whole bunch of incoming multicast. So we're getting a whole bunch of incoming multicast. Well, why aren't we seeing a 239.1.1.1? So we do a show run, and I put an access list on, then I debug it. And then what we see here is we see here the route packet from this gigabit source is 201. So we see it. It's coming in. That is us. That's the traffic we want. Okay? Now there's a problem, but we at least got past the part where we're supposed to send the traffic, and the first hop router is supposed to get it. So we know we're getting it. Bit of a problem with it, but we know we're getting it. So now we're going to go ahead and go to, I have it, but I'm registering. Trust me, they're tied together. So why is there no star comma G or S comma G? So if we do a show IP RPF 200.111.101, I know who the source is. Okay, that's fine. It's directly connected. But if we do a show IP RPF for 2.2.2.2, it's failed. No route exists. So if we do a show IP PIM RP mappings for 239.1.1.1, so I don't know who the rendezvous point is. Okay, so again, to your question, you need it everywhere. So the source needs to know, I mean, the first hop router needs to know, I'm going to go ahead and build this, but I'm supposed to, in that PIM registered join, I'm also supposed to put in there, this is unicast this, right? So I need to know who the rendezvous point is. We don't. So I don't know who the rendezvous point is. So again, static auto RP BSR, we're going to go ahead and do static with an override. So now we do a show IP PIM RP mapping, and 2.2.2.2 is your rendezvous point. And so again, it can be shared three ways: static auto RP BSR. So now I go back and do a show IP mroute on 239.1.1.1. We must be having a Mac Windows thing here. I usually present with my own laptop. I decided to Trust. So show IP mroute 239.1.1.1. And so we have the star comma G. I have the S comma G, but I have no RPF neighbor. So I have, from this perspective, my little who, what, whatever is not showing up. But I know who the RP is. I know where the RP is. And I know where the RP is because of the fact that I'm advertising it. But I don't know what my PIM RPF neighbor is. So show IP RPF, RPF interface has failed, no route exists. I don't have PIM neighbors. Okay, this is just reinforcing that you need it in both worlds. So even though I'm trying to send that unicast, and that's what's confusing to people, I'm trying to send the unicast, why do I need a PIM neighbor? Because if there's no way I can get it back, then there's no point in sending the unicast register join. I mean, that's just kind of sort of stupid. So I have no PIM neighbors. So I know who, I know where, but I don't know what my RPF neighbor is. So the first hop router doesn't know, and because of the fact that we don't have neighbors. So let's make a neighbor. So I made a neighbor. So now we do a show IP mroute on R1, and I have a neighbor. And I have, so the F means I'm registering it. So P means it's pruned. F means it's registering it. And so I actually am now, but you'll see this sometimes, it's called stuck in registering. Happens on the first hop router. This means I'm just sending the unicast. I'm just registering. The rendezvous point has not sent me a register stop yet. So why is this happening? Well, let's look at that, okay? But from this perspective, we know the multicast is being sent to the first hop router, and we know the first hop router is registering. Technically, that's all we were supposed to do right now. So let's go ahead and go to the next one. So we're registering it. And now what's supposed to happen is we're supposed to build an S comma G back. But I am registering. I'm stuck in registering, but I'm registering. So let's go ahead and figure out why this part's not happening. So in R1, I'm registering it, stuck in registering. Now here's the interesting thing. If I go to R2 and I do a show PIM RPF 200.1.1.100, okay, I don't have a neighbor for it. So this is what I meant, that I do the unicast register so the rendezvous point gets it, but it can't build that S comma G back. The rendezvous point itself does not know the source or where the source of the S comma G tree is. Because the PIM S comma G join must be built towards the source. And if R2, the rendezvous point, doesn't know where the source is because you didn't advertise the source server farm for the multicast because you're thinking the traffic just goes that way, I can't build it. So I can never send the PIM S comma G join back. So I can never send that, so I can never get the first traffic, so I can never send a register stop. So there's no RPF for the source, there's no route to the source. This is not uncommon for people new to multicast. The concept is it's going out that way. So remember, as we mentioned before, this is what's supposed to happen. And then as soon as we get the first traffic, so here's what's happening, right? The rendezvous point's supposed to send the S comma G backwards. It can't. So none of this is happening. So we are stuck in registering. Let's fix that. So let's go ahead and actually advertise. So we fixed the routing problem. So the rendezvous point now has the source. So if we're in the rendezvous point and we do a show PIM RPF 200.1.1.100, we can see that it's supposed to be right over there, and that's my RPF neighbor. So I advertised it, I have a PIM neighbor, we're all good. So now R2 has the necessary information it needs to craft and build that S comma G join and send it to R1. I know where, I know who, I know where, and I know what the PIM RPF neighbor is. So this is weird looking. How many people use iOS XR? So it's a little weird looking, but it's the same, right? I mean, I have my star comma G, I have my incoming interface, I have my outgoing interface, and so I told you, when the XR is actually the rendezvous point itself, you'll see RPF neighbor 2.2.2.2. That's me. And then you get that funky decapsule tunnel 0. It just means I'm the rendezvous point for this. A little more information. And I actually have an S comma G. So I actually now am accepting that source traffic. So from that perspective, we know who, we know where, we know what. And if we do a show IP mroute back on R1, we will notice that we are no longer stuck in registering, and there's no longer a prune. We are not in registering mode. So we are not stuck in registering. So this is important. This is the thing, and this is the reason why I was telling you all that scary stuff as to what happens. So if you have a black hole, it could be because of the fact that, so you've registered it and you're stuck. It could be because of the fact that the rendezvous point doesn't have a PIM neighbor back towards the source. You're not advertising the source. Could be accessless. Could be missing PIM neighbor somewhere in the path on the way back. Usual suspects could also be the multicast boundary configured for the multicast traffic. There's a multicast boundary command that it's confusing to people because you might say IP PIM multicast boundary 239.1.1.1, and it actually won't let it go this way or that way. But the unicast register join can go through. So that's confusing to people. So now we're back to here, and we've registered, and all that's good. So we're good with that. So now we're going to go ahead and we're going to do the cutting over part. That's really fascinating. So the default behavior of PIM SM is that the routers with directly connected members, receivers, will join the shortest path tree. So what's going to happen, kind of sort of a reverse there, but that's okay, is there is something on the last hop router that if the SPT threshold is not infinity, there's a command there, the default is 0, which means it's not infinity. So the default is to do this. In the past, a lot of people turned it off because of lower CPU and bandwidth to spoke branches, and usually your rendezvous point was up at the top anyway. But nowadays, typically, unless you have some reason to, just leave it at the default. So basically what will happen is that once the traffic comes down and I see the source in there, and I make that S comma G because I see the source, well, I get it down the shared tree and I see the source. I look at my routing table. Remember, the boy and the girl are in New Jersey. The rendezvous point, the dating services is in New York. Let's not always go to New York. Let's just go to a local park and go bicycling. So we're going to go ahead and do this. So we're going to cut over. So now the last hop router must answer 3 questions. It already sent the star comma G, so it had who's the root, where's the root, what's the PIM RPF neighbor, but that was the root of the star comma G. Now I have to answer the questions for the S comma G. And this is what I mean that if you're doing source-specific multicast, I'm now about to send a PIM S comma G join. So when we get to source-specific multicast, that part's going to go faster because sending an S comma G join PIM join S comma G is the same in ASM as it is in SSM. Who's the root? Where's the root? What's the PIM RPF neighbor for the root? So you're going to have to do that. But same thing. I would make you go through it, but it's the exact same thing. The last hop, so I do want to say one thing about DRs, because this can be confusing. So with DRs, you have the ASM designated routers for the receivers. Now, what sometimes people happen is they'll make this, now I'm not saying, but what they'll do is this is where receivers are, so they'll make like .2 the HSRP primary. And they'll assume .3 is going to be the multicast DR. There is a concept sometimes when we don't necessarily think it all through, that what will happen is that when I send the IGMP membership report, .3 will take it. And as a good last hop router, it will suck the traffic down. So yes, the traffic will come through that way. Now, but let's think about it. If I make .2 the HSRP primary, my traffic will go this way, but does that really control the traffic coming back in? Not really, right? Doesn't control the unicast coming back in. So sometimes people think they do the split. So the reason why I'm saying that is because of the fact that DRs and sources are different. So just wrap this around your head for a second. But it's not uncommon with HSRP, so that's why I'm tossing that one out there. So with HSRP, you're controlling how you get out, but you're not controlling how people get in. You're not controlling their choices. So what happens with source routers is the traffic comes in. Now, from here to eternity, I send the multicast traffic and .3 does the register join. Does that guarantee that .3 will be the one who will always send the multicast? Multicast gets built backwards. Multicast gets built backwards. So let's go back to this one. I thought I had another slide. So the multicast gets built backwards. So the source will send the traffic. Cody as .13 will pick it up. George will ignore it. And then Cody will register with the rendezvous point, which is a couple hops away. And then you, as the rendezvous point, will look up in your table the IP address of the source traffic. And then you will build an S, G, PIM S, G join on the way back. Hop by hop by hop. Okay, making George work. And now Cody gets a break. Okay, so Cody did the control plane stuff, but somebody else said, you know what, George, we're picking you. And that's because of the fact that George's IP address happened to be potentially higher, or somebody has an OSPF neighbor that's down to here. Okay, so what's going to happen is George is going to have to get put to work and the traffic is going to go through George. That's uncommon for people because they do think that they're going to make the DR for the source be this one. And then they tend to troubleshoot and get confused and stay in .3 trying to figure out what's going on there. But somebody else built it back. So that's an important thing to remember. So we've done all this and we've cut over, and now we're going to go through SSM. Now SSM is absolutely, so with SSM there is no star, G, there is no dating service. You specifically said, you know, I want to go bicycle riding with Bob. I specifically want 239.1.1 from this specific source. That source specific multicast. So there is no star, G, there is no rendezvous point. Because I can give you all the instructions in an IGMP version 3 membership reports. It's a special one. So with IPv4, it's IGMP version 3. With IPv6, it's MLD version 2. So from that perspective, what we're going to touch on is not the PIM the PIM S, G join, because you still know who's the root, where's the root, what's the PIM RPF neighbor in order to craft that PIM S, G join back towards that source, hop by hop. That's identical, whether or not you're building the S, G tree from the rendezvous point back to the source, or you're the last hop router cutting over to the S, G tree. An S, G tree is built the same when you do that PIM S, G join. What we're going to talk about with source-specific multicast is unique things in here that you need to know about. So from here, first and foremost, the multicast group needs to be defined everywhere as SSM. Every router has to know that there's not a rendezvous point for this. Every router has to agree that this is source-specific multicast. And it's going to be treated a different way. That's number one. Number two is your poll's going to be different. It must be IGMP version 3. IGMP version 2 does not have in the membership report format a way for me to specifically put a source IP address. Okay, so think of it like it's a new application to the dating service. Before, I could just say I want bicycling. The format itself that I submit didn't have a specific name on it. So this is IGMP version 3. Same thing with IPv6, MLD version 1, MLD version 2. It's a different form you have to fill out to say I want Bob going bicycling. Well, actually, yeah, there's no rendezvous point, right? Okay, so you're telling the last hop router, I want Bob and bicycling. So what you tell what you submit to the last hop router is different, still a different form. So you need IGMP version 3 to make this special, or MLD version 2. The other strange thing about this, which is very strange, I'm going to touch on this twice. This is not going to be too hard for you newer to multicast, but for those of you like me who, and this still trips me up, who have been troubleshooting and in multicast for so long, this is still like, oh crap, right, I forgot. Okay? What tends to happen with me is if a receiver's not receiving traffic, I will first go to the rendezvous point, and this is part of the key takeaway, so I'm jumping ahead. I will go to the rendezvous point in ASM mode, and I will see, do I have that the receiver's interested? If I don't, I hop over to the last hop router and troubleshoot there. If I do, then the question becomes for me is, do I have the first hop router? Do I have the source? If I don't, then I go to the first hop router. And I tend to troubleshoot towards him, okay? Or I'll come right here and I'll look and I'll say, okay, well, I'm getting the source traffic. Awesome, the source is fine. With source-specific multicast, I have gone to the first hop router multiple times and been like, the source is sending? Doesn't matter. Because the receiver doesn't care about it. The source sending, when it is ASM, gets me to the rendezvous point. The source sending from SSM just has me sitting there doing absolutely nothing with nothing on the outgoing interface list until somebody makes it all the way up to me. So we have one thing that we do, and that's it. So we're going to go ahead and still look for the pull, the SSM, and then the other SSM. So we're going to break this down. The pull is really, so I'm going to give you a big disclaimer here. It's the pull and the fact that it has to be IGMP version 3 or MLD version 2. There are statics that you can do to kind of sort of marry it up so you can get an IGMP version 2 and translate it to an IGMP version 3. It's the pull, and it's also likely somebody in the path doesn't think that this is source-specific multicast. That's your spoiler alert. Yeah? How did the last hop router know about the source? Who is the source? That's the question. The last hop router doesn't care. I'm just a conduit. It's kind of like, I will say, it's like mailing a letter. Okay? The receiver has to know who the source and the group is. So that would be like an IPTV where you're actually clicking on a certain feed, and you are now requesting, because the last hop router doesn't care. It's like, okay, you tell me exactly what you want, and I'll take care of you. The receiver, so how does the receiver know who the source is? It has to be based in the application that they are clicking on or doing to pull the information down. And so they need to put the IPv4 into the application. Actually, it is trickier than that. Their application and their stack must now send an IGMP version 3. It's really like going to the government. I'm sorry, that's the wrong form. The receiver now, if it sends an IGMP version 2, it's the wrong form. You have to get back in line. So it's actually not as simple. You have to send an IGMP version 3, which for some people, that's not just to put in an IPv4, because they don't have a place to put that in the IGMP version 2 form. So they need a new form. And so they need IGMP version 3. That is the part where the coding is harder. So what a lot of people will do is they'll actually use statics, IGMP statics. So then you, as the developers, designers of your environment, have to know that there is one and only one source of the CEO broadcast. So when they're asking for this one thing, you're going to go ahead and you're going to translate this IGMP version 2 into an IGMP version 3. Yes, sir?
That process is outside of PIM, though, right?
The question is, that process is outside of PIM. Yes, that still kind of sort of lives in the pull world. And so that's the IGMP. So it's still multicast, but it lives outside of PIM, yes. Okay. So, so basically what happens is the first thing you have to realize is by turning on IP sparse mode, you're just by default turning on IGMP version 2. You're not turning on IGMP version 3. So you're not listening to IGMP version 3. And they actually are different multicast groups that they go to. IGMP version 2 and IGMP version 3 membership reports. So if you do a show IP mroute here, first and foremost, I want you to see that I've got a big S. That's not good. Okay, big S is not good. I told you before that a big S is sparse mode, which is ASM. I need it to be a small s, just FYI. So we're going to have another problem here, right? Should you ever see a star comma G for something that you think is source-specific multicast? No. Okay, that's clue number 1. I kid that there's a difference between facts and clues. Facts are like, this is a star comma G, but clue means you have knowledge. So a fact is star 232.1.1.1. A clue is because you have knowledge, which hopefully as you're getting from Cisco Live here, that 232 is actually supposed to be SSM. But in some of our platforms, we will mandate that it will be, and you have to override us that it's not if you want that to be ASM. And in some of our platforms, because we like to keep you on your toes. Sorry. You should never see a star comma G for a group that you think is SSM. So that is clue number 1. But let's go ahead and say that I need to get this SSM IGMP version 3 membership report. So we see PIM is enabled. That's great, because gigabit 105 is my interface towards him. So PIM's enabled, because I'm not going to do that to you. Because everything that we did from a troubleshooting perspective before, I'm assuming that you've already done that. Now we're just doing the stuff that's unique. And is IGMP version 2 and, and IGMP version 3 has to be enabled. If IGMP version 3 is not enabled, I'm not going to get anything. Okay? But PIM's enabled, but let's go ahead and say we're going to do a show IP mroute, and I'm in R5, and I got the outgoing interface list, which means what? I got an IGMP. Okay? So I got an IGMP from him. How many people are running SSM, by the way? Just a couple, okay. So I got an IGMP for him, which is good. Otherwise, he wouldn't be on the oil for 232.1.1.1. But there's a problem here, and the problem is that if I do show IP mroute SSM, doing show IP mroute SSM is very similar to doing show IP route OSPF, show IP route BGP. Show me the routing table, but only show me the stuff that's BGP. Show me the routing table, but only show me the stuff that's OSPF. This is show me the multicast routing information base, but only show me the stuff that's supposed to be SSM. It's empty. And I got a star comma G, and there's a big S. So number 1, big D is dense mode, big S is sparse mode, B is BIDR, and small s is SSM. So I do not realize that this is source-specific multicast. No one configured me to do that. Even though it's 232.1.1.1 in iOS, they did not have that by default. In Nexus, they had it by default. In iOS XR, it's on by default. So this is one of the biggest things. So there's the two biggest things for troubleshooting SSM. Number one, every router is going to say, is this ASM or SSM? Number two, you need an IGMP version 3 or you need MLD. So our problem here is that we think that this is source-specific multicast. So the last top router is configured for this group to be in an ASM group. So it's trying to figure out who the rendezvous point is. So if we look right here, you can do a config T and you can do an IP PIM SSM. And you can just say default, which is what I'm going to do. Because 232/8, according to IANA, is supposed to be default. You can override that because you're probably not sending this out into the internet. And so some people historically were already using these, so they got kind of sort of upset with us. And so you can override that even with the Nexus 7Ks and the other platforms. You can override it. I'm not sure you can override it on the iOS XRs, actually. If you need to know that, put it in the Spark room, I'll find out. So again, why did I pick him? I picked him because he has the higher IP address. So exact same things that happened before. An SSM is an SSM is an SSM. So I send it to R4. So with this group now, an SSM group, and the last hop router asks itself, where is the source? Who is the RPF? So in R5, we do a show IP mroute 232.1.1.1. I picked, again, R4 because the same rules apply, whether you're sending a PIM star comma G join or a PIM S comma G join, whether you're an ASM or SSM. I'm going to pick the neighbor. If I have equal cost paths, I'm going to pick the neighbor with the highest next hop IP address. So I'm going to pick R4. But now look, we have a small I, and if I do a show IP mroute, the star comma G has gone away because I have said 232/8 is now source-specific multicast, which means it should not have a rendezvous point because we're married. Or we're at least getting kind of sort of serious with Bob or Bobette. Sorry, most of you are men. Or Bob for those 10%ers. Sorry. Okay, you know, it's just so sad. So now we have the little s, and we're going to send the PIM S comma G join to R4. R4 is not going to do anything different except for the fact that there's no IGMP version 3. What it's going to do is it's going to get the PIM S comma G mode, and it's going to go ahead and send it. So let's go to R4, and we do a show IP mroute, and we made sure that it's the SSM range. If I received an S comma G and I'm R4 and someone forgot to say this is source-specific multicast, then when you do a show IP mroute, you will again see a star comma G. Now in this situation, I told you that these were Nexus 9Ks. So show IP mroute, this is a Nexus 9K. So that's why you have Ethernet stuff. So I got the incoming interface for 200. It's that way over there. And then the outgoing is he wants to receive it. Just trying to show you all the different combinations of the different types of ways that So he knows that it's SSM, and he knows who the source is, he knows where it is, so he's going to go ahead and he's going to send a PIM S comma G join to R2. And so it goes to R2, and really not too sure why this other thing happened, so we're going to click through it twice. Yay! Wow. Okay, so we're going to go ahead and we're going to send it to R2, and then R2 asks itself, where is the source, and who is the RPF neighbor for the source? So it gets it, and it goes ahead, and we're in XR now, so we're going to go ahead and do a show mrib IPv4 232.1.1.1. Now, what you'll notice here is it doesn't have a little s because this is XR. But when I said 232.1.1.1, I didn't get what? I didn't get a star comma G. So we can go ahead and we can just move on and send it over to R1. Now, on R1, we do a show IP mroute 232.1.1.1. What's the problem here? I'm sorry? There's a big S and there's a star comma G. Everyone along the path has to agree that this is SSM mode. Okay? So he didn't agree, so we have to fix that because he's going to be going ahead and he's trying to register. He's like, oh, the rendezvous point is this because we did before IP RP address 2.2.2.2, no access list override. Okay? So I'm going to assume that for all multicast 2.2.2.2 is my RP. And I didn't put in there, and this was an iOS box, I did not put in there IP PIM SSM default. So I didn't distinguish. So we need to do that because we can't have that happen. So R2 sends it to R1, and R1's all messed up. So we put IP PIM SSM default in, and then we have this. Ta-da! And we have only an S, G. Now here's the interesting thing. We've made it all the way back here. Now in ASM mode, when you're troubleshooting, so if you troubleshoot in SSM, this is what happens to me, I go all the way back here and I think to myself, oh, well in ASM mode, the S, G wouldn't have shown up on this router if the source was up and running. In SSM mode, the source didn't even necessarily have to be involved yet. The S, G will show up all the way back at Bob's front door with a bicycle waiting. Okay? So because the receiver can get the PIM S, G mode all the way to Bob's front door, waiting with a bicycle, you know, and then the source hasn't started. So in my mind, that always trips me up still. I will troubleshoot source-specific multicast, and I'm so used to, if I see an S, G in the first hop router, then the source must have sent, because in ASM mode, that would never happen. In SSM mode, it will happen. So this does not necessarily prove that the traffic has actually been sent at all. But note now that the traffic has not actually been sent from, so if we look here, and if we do a show IP M route count, I've got nothing. So that is another strange thing with SSM. So for SSM, the troubleshooting is exactly the same, except everyone has to agree that it's SSM. You need an IGMPv3 or an MLD pull at the receiver. It's a little strange because you can get an S, G all the way back at the first hop router, and he hasn't even started talking yet. And so from that perspective, we have to realize that, so we have one more step with SSM. Because again, that S, G never would have shown up in ASM without him talking. So that's the additional step that you have to do here is to look. So if your guys aren't actually working. So this is getting it all together. And what we're gonna do real quick right now is we're gonna do final takeaways. I'm gonna repeat this. Multicast trees get built backwards from the root. Multicast traffic in ASM and SSM are triggered via a pull. It's high on the food chain, right? So again, if you aren't advertising your source subnet, that's a problem. It relies on your underlying routing protocols. Who's the root? Where's the root? What's the PIM RPF neighbor for the root? And what we're going to do here, and also don't forget the pull, we're going to do a quick key takeaway. So the problem is you're going to go on a ride along with me. So troubleshooting with fish. So I get pulled into someone's environment, and they say that there's no receivers at all getting multicast. None. Okay, that's an all or nothing, so that's easier. Okay, that kind of sort of reduces where I'm going to go. But first and foremost, what I'm always going to do is I'm going to go to the rendezvous point. And I'm going to be like, okay, which way do I want to go? Because remember, we had the two main steps. We had the receivers getting to the rendezvous point, and then we had the resources getting to the rendezvous point. So I'm going to go right to the dating service and figure out where the disconnect is. So I'm going to start here, and at the rendezvous point, I'm going to do a show IP route. And for the group that they're complaining about, I'm going to go ahead and see, is there a star, G, so is there a star 239.1.1.1 with an outgoing interface list that is heading towards the receivers? That will only get added if somebody sent me a PIM star, G join for 239.1.1.1. If I have no outgoing interface list, and it's all the devices are not getting it, then I'm going to be like, okay, pivot. I'm going to pick one of them, and I'm going to jump all the way over to the last hop router, and I'll start troubleshooting there. Why is that IGMP not making it up to the rendezvous point? If it is there, then I'm going to say, okay, well, I got oil there. Now, the next question is, and this gets a little bit tricky, so what if the oil is there and the S comma G, but let's just make this simple. So, okay, so let's say the oil is there, so they have already started. Do I have an S comma G? If the multicast traffic is working, we would have had a register, and I would have built it back. And the S comma G would have an incoming interface and would have an outgoing interface. Do I have an S comma G? No, I don't have an S comma G. I'm going to go to the first hop router. Some receivers getting multicast. Again, I'm going to go to the last hop router now, and I'm going to do this. I'm going to go to the last hop router of the one that probably has experienced it the least. So I'm going to ask for someone that's like, oh, well, you know, sometimes we get it over here, sometimes we don't, but this guy never gets it. Okay, well, maybe you're connected to some router that doesn't have a PIM neighbor. So maybe I can zero in on you, which will make it easier to troubleshoot. And hopefully one of your paths overlaps with some path that you're getting back and forth to. So I'm going to go to the all or nothing one first, because that's going to be easier to troubleshoot. I'll be able to do it faster. So I'll pick one. I'll typically go to the one that's not getting any. And I'll find out whether or not, is the RP address messed up? Is there a pull? Now, I'll have in the back of my mind that somebody else is getting in and out. So if you don't have an RP address, I'll quickly put it in, see whether or not you're getting the traffic, and then I'll switch over to that one. But if you have the RP, then I'm more likely that if I stick with you, then I might get to some path that might be impacting you as well. But if some receivers are having issues, I'm going to go ahead and go to the LHR of the most broken receiver, and then hope whatever was there is going to help the other ones as well. SSM troubleshooting. I'm just going to start the first hop router, right? Because if I start at the first hop router for SSM is kind of like that receiver, or the RP. For SSM, I'm going to start the first hop router because if the receiver didn't send the S comma G, then it won't make it all the way to Bob's front door. And so now, from an SSM perspective, I'm the connection between the receivers and the source. The first hop router is. So I look this way, do I have an oil? If I don't, I'll go to one of the ends. If I look this way, am I getting any traffic yet from the source? And that's it. I'm going to go ahead and be here for questions afterwards. I have lots of stickers. I give silly stuff away because it's a work hard, play hard thing. So please feel free to, please fill out your evaluation forms. We take those very seriously. They really resonate as to what you all want and are looking for, and the speakers are making sure that we're doing the best things for you all as the attendee. Thank you so much. Have a wonderful day.